Okay, so hello everyone. We've been asked to do a demo project just to show off a simple use case of Mesos. Unfortunately, we don't have all the time in the world, so we can't do anything extravagant. But this should hopefully show everyone, the types of things you can do, what things look like, and how to, if you've not used Mesos before and you want to dive in, this is a good introduction. So you can probably copy what we've done, maybe do it yourself, have some fun on the weekend, whatever. So if anyone has any technical questions or any questions in Dutch, I have my Dutch giant here who can translate it to me with interpretive dance, which I've been told after the last company meeting we had, I got very good at, so we'll see. So the people who were involved in this project is Willem, here at the top. He's one of our infrastructure engineers, and he's the guy who does all of the networking and load balance and stuff. So don't ask me any of those types of questions. Daniel, he should have been here, but unfortunately he prefers the company of his girlfriend. And unfortunately, you guys don't compete, but it turns out me and Willem don't have such company, so that's why we forced the volunteers. And then there's me at the bottom here, so hello. And yeah, so go on to the next slide.
Yes, Jasper has got this little lunchbox, and there's a green one over there as well. So I like to play with Raspberry Pis in my home. I got a few of them, turn on the lights on and off, play with temperature and so on, do some little experiments. I don't like to solder, so I just buy the little things that you can click onto it. That's way easier, because I like to play around with the software, not too much with the hardware. Of course you need some hardware. We work for a company that does stuff with IoT. Can't really talk about that, so that's why we got those devices. This is also an IoT device. It's a small Raspberry Pi Zero, and it has a sensor on there. There you see the blue thingy. That's the actual sensor. Is it actually blue, Jasper? Yeah, the sensor on there is actually blue, so if you want you can pass around the box as well. And that's actually a temperature and humidity sensor. And this thing runs a small Python script and is connected to the Wi-Fi. And sends that readings to an MQTT broker. MQTT broker is a lightweight protocol to send messages, mostly used for IoT use cases. It's powered by a little power bank, so it can move all around. And it has a fancy LID that will come in handy later, because that one is green and Jasper got the red one. And maybe Jasper wants to pass it around as well. So this is a small device. The Python code is like 10 lines of code. Where we take the reading, plus you use some libraries, take the reading and publish it to MQTT. We make sure the server stays up with systemd. If it fails, we just restart it, and most of the times that works. So it's nice and easy. Well, we're here for DCOS, so Michael explains how we do that.
So this is a simple slide, which is why I'm doing it. This is this is our infrastructure on Amazon. And we're using the default cloud formation script, which you can get from the Mesos website, which is, if you just want to get going and want something simple so you can play around, on the actual Mesos website, you can create your own local cluster using Vagrant on your own machine, if your machine is powerful enough. If you need a bit more juice, you can go to one of the cloud providers. You just click on one of them. This is going to start the cloud formation script in AWS. So if you just want, a single master cluster, just want to play around, click it. I see a very scared face over there, but you just want to get going. This is how you do it. And
if you got a credit card, you'll get going.
Oh yeah, exactly. If you got money. But so we have a little cluster running on Amazon, which if you go back to the slides. This is what we have running on Amazon. It's very simple. We have one master node, one public node, and 2 private nodes. And this is how the data ingests. So wherever the nodes are, I see the green ones there. I don't know where the red one went. There we go. Thank you, Pedro. This is the red one here, and that's the green one there. Very simple. And we're pushing the data through Malcolm LB, which is our load balancer, to Mosquito, which passes it through to a service we have running Akka. And finally, after Akka has processed the data, it passes on to InfluxDB. So it's a very simple ingest of data, but it helps you see how the clusters can be scaled out, and get a feel for what actually you can do on DCOS and Mesos.
Yeah. This akka app is written in Scala. It does a very simple job. It takes a stream of data from an MQTT topic. It subscribes to that one, streams it, transforms it to a useful format. Because we have some raw JSON, but you could imagine having an IT device that's very limited in power, doesn't support large messages or large memory. So you use some binary protocol, and you can do some decoding there in place. In this case, we just transform the JSON to some useful format for InfluxDB. And then we have another actor system on Akka that publishes it to InfluxDB. Nothing special there. Every message that comes in on our broker, we transform it and put it into InfluxDB. Well, why InfluxDB? InfluxDB is a time series database. So if you got measurements, they mostly got timestamp, the degrees Celsius, and the humidity level in percentage. And with InfluxDB being a time series database, you can easily aggregate over all the data and display that. Yeah, just storing data, we don't have anything useful there. So we also want to show something. That's where Grafana comes in. For easy dashboarding, you can connect literally any data source to Grafana and make some nice graphs and dashboards. Well, Grafana also runs as a container on DCOS, and we use again MarathonLB to expose that app to the internet, to the user. Well, how does it look like? Well, we've got a green sensor, those ones are greens, the other one is red. I don't know where green is at the moment. It's next to the window, so it's a little colder. Pedro is blowing his hot air over the red one. It's getting way hotter. And you see, the data is coming in real time. It refreshes every second. And every second, you see a few new measurements coming in. Here, you can see the red one popping up already a bit. So, it doesn't take much time. As soon as the temperature rises on that device, there's like a few seconds delay between that device reporting the temperature and Grafana showing it. Bear in mind, the cluster itself is running on Amazon, so we publish a message, goes over Wi-Fi, goes to Amazon, we process it, and then we show it in Grafana again. And that all within a few seconds. We have some historic data. You say, show me the last 7 days. Didn't implement the restart feature on the systemd server, so some internet thingy went lost somewhere and it broke. But now I implemented the restarts when it gets a failure, so those empty spots shouldn't happen again. Well, you wonder how all that looks because Michael promised something with DCOS.
Of course, that's why we're here.
You want to tell something quickly about this?
This is DCOS, and I'll pass you over to my DCOS expert.
Now here you got some basic dashboarding, so you see the amount of CPU used, memory and disk. We don't use any disk at the moment, I see. And we got 5 tasks, and we only got 3 actual nodes where we can run some workloads. Now, what runs on there? Servers. We got Grafana in a container, InfluxDB, the IoT collector, that's the Akka app collecting the data from Mosquito and sending it to InfluxDB. We got MarathonLB and Mosquito. Well, for some of these, you see this fancy label in front, and those come from the catalog, the universe, the app store that Taco talked about. And here you can see the certifieds, which are certified by Mesosphere, and all the open source from the community. Just one click, wait a few seconds, pops up. So that's really easy, because then we don't have to configure InfluxDB and MarathonLB ourselves, for example. You also have Grafana in there, but Daniel encountered some problems there, so we just took the raw Docker image and that one went up immediately, but we didn't care about looking into it. So that's why we chose that one. So, like I told you, the MarathonLB is a universe package which you simply can install, and it automatically exposes your applications. Not every app, you have to give it some special configuration, but the developers themselves can specify how this app should be accessed externally. The MarathonLB runs on the public ones, on public slaves, that have an Amazon load balancer in front, so you can also have multiple public slaves. And that one connects to the apps, and it knows which app to reach through the marathon state itself. So it reads the marathon API, and based on that, it exposes the apps. Well, how does it look in the config? Let's open up Grafana. So the only thing you have to do is provide some labels. I provide the HA proxy group because internally Marathon LB is HA proxy, which we all know. We put it in an external group so it's accessible over the internet, and we give it a vhost. Well, this is possible with Grafana because it's HTTP traffic, so we can inspect the headers, and based on that we can route the traffic. You can do some more complicated routing rules as well, but for that you will need to consult the documentation. For Mosquito, we can't do the trick with the vhost because it's TCP traffic, so we don't have the HTTP headers to assign a vhost. So we need some other configuration for that. We just put it in a TCP mode and use the assign a CNAME record to the Amazon load balancer, and then we can simply access it. And that's the only thing you have to do. There's one more special thing that you have to do, is define the service port. Because by default, Marathon LB will do on port 80 and port 443 for HTTP and HTTPS traffic. We want this port is mostly used by MQTT. So if we define the container port, that's the actual port where your application is listening. And we define the service port, so Marathon LB exposes it over that port. That's the only config you have to do to configure this load balancer. So you can call me a load balancer expert, but of course, it's this easy.
So great, isn't it? So great. And if you go back again to the page and you go over to nodes, we can actually see, you know how I showed you before, you know, the public and private nodes. Down here, we should see this node here, and you'll see one task running on it. And that's the Marathon LB, which we just covered over. That's the only thing running on the public node. And if you look back on the nodes again, you can see the stuff we have on the private nodes. So, for example, on this private node, we have the Yaka service and the Mosquito service. And the other one, I imagine, has Grafana and database, InfluxDB. So you can see, you know, you personally don't have to worry with Mesos, you know, where your resources are being started and where things are running, because it manages it all for you. I mean, it's useful to know what nodes are on, you know, in case things do go wrong, but ultimately, you know, it manages everything for you, and you just let it do its thing.
You just go to the dashboard and see there's so much CPU left, so I can still use that.
So improvements. This is, you know, obviously just a simple demo application. There is several things you can do to, you know, help scale it out, because the wonderful thing about using, you know, container orchestration or your resource management and things like this is how much you can scale it. And you know how you brought out you can scale outwards. Obviously that's the big concern we have in IT, because it's getting to the point where scaling upwards is becoming, you know, harder and harder and harder, and there's more bottlenecks of resources that just, you know, become such a pain. We're using, well, the first thing, Kafka, we can buffer the raw data, and we can, you know, use Kafka streams instead of Akka to transform the data. The other thing you can do with Kafka is also we could separate hot and cold data. So I'm not sure if you can do it with Grafana, but we had our own graphing solution. Instead of relying on the data to have already been written to the database, we could use hot data from Kafka directly to write directly to the live service. On top of that, there's one other point I want to make about Kafka. Oh yes, we could also use and the other thing is that we were using Marathon LB in the example we gave, and the main reason why we were using Marathon LB is because you can set up Marathon LB for free. There is Edge LB, which is, as I understand it, for enterprise only. And the wonderful thing about Edge LB is that you'll see here we have pools, and you can scale out the pools which are responsible for being load balancer for your applications. Because if you go back to the Marathon LB graph before, you won't see you talk to mouth and LB directly. And the problem with this is when we're talking about huge clusters, mouth and LB it can't cope, it dies basically. So being able to scale everything out with Edge LB is quite important, and also the fact that Edge LB integrates quite well with Mesos frameworks, as I understand. Any other improvements you want to mention?
Yeah, for HLB, for Marathon, you define it as a developer per service. And on HLB at the moment, you define mostly the ops people, define centrally. So not every developer can just expose an application over the internet over some port. But here you have more control over what gets exposed. You can do some complicated rewrite rules, have different pools for MQTT and for HTTP traffic, for example, which have need different templates for HA proxy, different timeouts, memory sizes. That's way more flexible as well.
A nice introduction to Mesos, and we can go back to the Grafana after this so you can play around and see how it affects the graphs. But it's just, a small demo project just to show how easy it should be to scale everything out on Mesos, and all of the instances we had. For example, if you just go back to GCS quickly, things should be able to be, scaled, and you can change the scale out your instances and nodes. And as you scale things out, you'll put them, obviously onto more nodes, more physical machines, and so you can, as your application grows in use, you can just resize. And the way we have it, we can just spin up a new Amazon EC2 instance, get Mesos provisioned on there, and then bam, we have a whole new set of resources to play around with, without really having to be concerned about, oh crap, our stuff's gone down, what do we do? And we can just bring up a new instance just like that, very easy. Yeah, so we can go back to the graphs. People can just play around with that way. So that's everything.
That was it, I guess.